Okay, what will be our first derivative in this case? First derivative y1 is equal to, suppose we keep sin bx plus c as it is, then derivative of e raised to ax is a e raised to ax sin bx plus c plus we keep e a raised to x constant into b sin bx plus c.
So cos bx plus c.
Sorry, derivative is cos bx plus c, right? So e raised to ax goes out as a common factor, a times sin bx plus c plus b times cos bx plus c. That is where we are supposed to restore the form. And by restoring the form, we cannot afford to have so many terms, and therefore we use our trigonometry skills to restore the form, saying that e raised to ax dividing and multiplying by root of a square plus b square, we get a upon radical a square plus b square sine plus b upon radical a square plus b square cos something. That makes it radical a square plus b square e raised to x. This is sine cos plus cos sine. We want to, because we are dealing with sine right now, we would like to have this term also sine. Therefore, it is sine. This term is ax plus, sorry, bx plus c, and this is going to be some angle phi. So if it is where phi is tan inverse b by a, because this is our sine, this is our cos, therefore sine upon cos is going to be b by a, which will be tan theta, tan phi, therefore phi is equal to tan inverse. Okay, and then we can assign this, we can write this also as r, where r is equal to, and r is equal to radical a square plus b square. Okay, this is constant, so this is c is constant and phi is constant, and again a raised to x sine something. So we have practically restored the form, and therefore if we want to take second derivative, what is going to happen is y2 will be, r will be multiplied once again, so it will become r square e raised to ax sine bx plus c plus 2 times phi. One phi was there and one more phi will be added. This is second derivative, therefore yn is equal to r raised to n e raised to x sine bx plus c plus n phi, where phi is tan inverse of b by a and r is radical a square plus b square. This is important. Similarly, if we have function y is equal to e raised to ax cos a bx plus c, find yn. Okay, write down what is yn. It is going to be similar, and then by using this we will try to solve one problem. I give you 2 minutes to find out what is yn. So except sign, it becomes cos. That is the only difference. R raised to n e raised to x cos bx plus c plus n. Okay. Now, having done this much, let us try to find out nth derivative. Here you are expected to use limits. Important thing in this is you are supposed to use Leibniz, but you will see that because one function is x square, after two derivatives, the third derivative is going to be 0. So they are not going to be n terms which are going to be present, because after some time x square will disappear. All those derivatives will be 0, and therefore total number of terms which will be available will be much less compared to what you are imagining. Okay, so x square is to be assumed the first function, and e raised to x cos x is to be assumed as second function, and then apply Leibniz to get the answer. It is as simple as that, and therefore there are, for all practical purposes, there are 3 terms in the answer. So next lecture I will solve this on board, and you try your level best. If you finish, you can match your answer next time.